Each of the contributors today researched their topic, wrote a paper, as all of you did. You selected these topics from the list of papers that were generated this year. As an instructor and faculty advisor for this symposium, I want to thank and congratulate each participant for their efforts, courage, dedication, and by participating, these individuals perpetuate this event annually. I am both proud and honored to present the work of these individuals as well as the rest of the class. At the conclusion of the presentations today, I have for each of you a CD with all of the papers on it. You may retrieve your original disc or CD that you gave to me. You will receive your paper, which has been graded. It will contain your final exam grade and will also contain your final grade. And all that happens at the end. Each of the presenters, at the end of their presentation, will entertain questions, but we'll hold that to a maximum of 5 minutes. At this time, I would like to dedicate the symposium to Dr. Mary Lou Mosley, PVCC Dean of Learning. Would you please come up? Dr. Mosley has always supported the initiatives of the academic divisions, especially those of the science division. Through her hard work and leadership, the science division was able to develop and implement a micro program this year. Personally, Dr. Mosley has been a supporter of, an advisor for me. She is well respected by the faculty and is an advocate of learning, and as educators and students, we acknowledge her efforts, and we want to present her with this plaque. All right, our first paper this afternoon, we're going to be talking about Accutane, miracle drug or killer, and our presenter is Sarah Beth Bahani.
All right, my topic today is on Accutane. Isotretinoin is its generic name, so it's better known as Accutane. It's an oral medication used for the treatment of severe acne. It has been sold under many names, such as Amnestine, Accutane, Roaccutane, and etc. It's a derivative of vitamin A, therefore it's very strong. It's digested in the liver. There are many treatments for acne prior to the development of Accutane, which include antibiotics that were for severe acne. However, these antibiotics only worked against one of the many causes of acne, the Propionibacterium acnes bacteria. However, furthermore, many of these antibiotics used over a long period of time developed a resistance against these bacteria and therefore, in the end, proved ineffective. This review will talk about how the use of Accutane is often necessary and over-criticized by the public for its potential side effects. Acne vulgaris is an inflammatory disease of the skin caused by the changes in the pilosebaceous units. Hair follicles, or better known as pores, are often blocked, causing oil to drain to the surface, and the pore gets blocked and bacteria begins to grow. Acne cases vary from person to person, from age to age. However, it's mostly prevalent in teenagers. The mechanisms involved in the creation of acne are not exactly known. However, an abundance of hormones, abnormal shedding of the cells lining the follicle, and water retention in the skin have been recently put as potential causes for the development. A normal hair follicle has the tip of it open, but however, a blocked hair follicle, which is shown in the second picture, is clogged, therefore causing acne. There are many types of acne, depending on the severity of the case. Mild acne generally takes the form of comedones, such as blackheads and whiteheads. Severe acne could take the form of cysts and nodules. Whiteheads result when a pore is completely blocked, trapping oil, bacteria, and dead skin cells, causing a white appearance on the surface of the skin. Blackheads result when a pore is potentially or partially blocked, allowing some of the oil, bacteria, and dead skin cells to slowly drain to the surface. The black color is not dirt, but rather it's the skin's own pigment, melanin, reacting with oxygen in the air. A blackhead tends to be a stable structure and can often take a long time to clear. Pustules are similar to a whitehead, but they're inflamed and appear as a red circle with a white center. And these were the mild to moderate cases. However, severe acne is characterized by nodules and cysts, and that's the kind of acne that Accutane is able to cure. Nodules, as opposed to the lesions mentioned above, nodular acne consists of acne spots which are much larger and can be quite painful, with oftentimes lasting for months and can result in scarring. Nodules are large, hard bumps under the skin surface, and it's advised not to squeeze them because you can potentially scar your skin really badly. Also, cysts can appear similar to nodules. However, they're pus-filled, and they can be as having a diameter of 5 millimeters or more. And they can be painful, and again, scarring is common with most of the severe acnes. And here's a picture of the nodular acne, except this is pretty mild because I tried not to make it too gruesome. Drug treatments. Lately, many drug companies have come out with even over-the-counter pill medication, and as well as prescription medications to cure acne. However, the one safest bet, not safest, but the best and most effective medication has been proven to be Accutane. For example, for people with very mild acne, Clearasil, which is an over-the-counter face wash, can be used, but for someone with nodular acne, sometimes Isotretinoin or Accutane is the one and only option. And the doctors generally use it because they don't have another option to go. Salicylic acid is a topical medication, also used in the treatment of mild to moderate acne. It is a beta-hydroxy acid. Its mechanism causes skin cells to slough off more readily, thus preventing the pores from clogging up. And benzoyl peroxide, which is a very common drug used, and it's now, I think, recently been available for over-the-counter medication, is a chemical in the organic peroxide family. It consists of two groups, benzaldehyde, with hydrogen of the CHO removed, joined by a peroxide group. The topical medication is very effective for mild to moderate acne. Clindamycin is an antibiotic also used for acne and for the controlling of acne to prevent further breakouts. It is often used with other medications. For example, clindamycin and benzoyl peroxide are used and together to provide better results. For women especially, because due to acne is partially caused by hormones as well, such as high testosterone levels, for women, contraceptives such as birth control have also been another method to reduce the breakouts for mild to moderate acne. The pills lower the production of testosterone because of the high dosage of estrogen. Skin improves after months of usage, but after you stop the medication or stop the pills, then your skin goes back to normal. Vitamin A acids such as retin A are also used for the treatment of acne. The mechanism of tretinoin or vitamin A acid is not exactly known, but current evidence suggests that topical tretinoin decreases cohesiveness of follicular epithelial cells and with decreased microcomedo formation. Additionally, tretinoin stimulates mitotic activity and increased turnover of follicular epithelial cells, causing extrusion of the comedones. This tretinoin is also a milder form of Accutane. It's a topical medication rather than an oral medication. However, for moderate to severe acne, and oral antibiotics are used, such as tetracyclines. These groups of antibiotics have been used for a broad range of many purposes, for example, mycoplasma, pneumonia, but they're also used for the treatment of acne. The tetracycline group includes doxycycline, minocycline to treat moderately severe cases of acne. However, tetracycline treats only about 50% of the bacteria, and oftentimes bacteria become resistant and the medication proves to be ineffective. Finally, isotretinoin is the last of the effective medications used. It's also known as Accutane. This is only used for severe cases of acne or cases in which acne has been recalcitrant to other treatments. But the mechanism of isotretinoin is not known, but it is known that it changes DNA transcription. Oftentimes, a side effect of the drug deters doctors from either prescribing it or from patients taking the medication. The history of isotretinoin is it was invented in 1979 by Roche, who came out with the brand name Accutane or Accutane, and the drug has been used to treat severe cases of acne since then. However, over time, its side effects have proven to be almost unbearable for many patients. An early effective treatment of acne was high doses of the fat-soluble vitamin A. At these dose levels, effects such as reduced production of oil and dry hair could be noticed, often dry eyes and dry lips as well. However, the vitamin also had many prominent side effects which have inhibited its widespread use. The development of the derivative of retinoic acid, which is also tretinoin, it's 13-cis-retinoic acid, and its release in 1982 was a great step in the treatment of acne, because before then, many other medications had proved to be not effective in cases, and severe cases, such as the ones that need Accutane. The synthetic compound provided better therapeutic benefits than vitamin A, while also producing fewer side effects. In 2002, their patent expired, and therefore the generic isotretinoin was also sold. And now there are many companies selling cheaper versions of the drug. However, today it's usually prescribed for acne that hasn't been able to be treated by other medications such as the antibiotics, or for ones that simply no other antibiotics or medication could cure. Effective March 1st, 2006, they've also put tighter regulations on the drug with the iPledge program. Now that pharmacists have to monitor the daily practices of the patient, the habits, and also doctors are required to register the students in the patients in the program to monitor them, because the drug is also for women causes birth defects. Side effects include, but are not limited to, the hair loss, arthralgias, decreased night vision, back pains, or muscle pain, bone pains in general, and depression in some severe cases, and not oftentimes, but sometimes leading to suicide. The biggest birth defect, however, is in females, because the drug is classified as a Category X in the United States, the United Kingdom, and Australia, which means that it's a high risk for birth defects. It must be prescribed under the policy that women taking the drug take two forms of effective forms of birth control. Otherwise, the females have to sign a contract to stay abstinent for the course of the treatment and up to 1 month after the treatment's over, because Accutane can stay in your body for up to 1 month after. Birth control is to be taken from 1 month before to ensure that the chance of pregnancy is highly minimized, and the female must test negative to a pregnancy test before the treatment is started. The patients also, men and women, have to take a blood test monthly for the doctors to check the cholesterol levels and the and the lipids and for the body metabolism. Another suspected side effect of Accutane, which is warned in all of the packages that are received, is the possible effect of suicide. Accutane has been linked to many cases of depression and suicide. However, the claims cannot be proven or disproven, so the company, Roche, originally put the warning on it to warn people that it could be a possible side effect. Therefore, Roche and now other manufacturers of the drug have a warning on the drug. Furthermore, patients are given packets of information that they need to sign and review before they can be given the drug, because they need to understand the risks and the benefits of the drug. However, nonetheless, a reported 2,000 females on the drug have become pregnant between the years 1983 to 2002, despite the efforts on behalf of Roche and the other drug companies. Currently, the federal government, the FDA specifically, has started a program by the name of iPledge to monitor the patients on Isotretinoin. Before a prescription is prescribed by a registered doctor, the prescription is to check the information and have an interview with the pharmacist administering the drug, is to have an interview with the patient regarding his or her sexual practices and activities. Oftentimes, delays can occur with prescriptions, and many doctors are discouraged and deterred from the drug because of its high liability. There have been also many lawsuits against the drug because of the potential side effect of depression and, at extreme cases, suicide. Charles Bishop reported a 15-year-old student pilot flew a light aircraft into a Tampa, Florida building on January 5th, 2002. His family claimed Accutane had caused severe psychosis in the boy and filed a $70 million lawsuit against Hoffman La Roche, the company that originally started the drug. However, when an autopsy was performed, they found no traces of the drug. So therefore, it can't be proven that suicide is a direct cause of Accutane. Also, Bart Stupak, a Michigan congressman, had alleged this connection also ever since his son, BJ, an Accutane user, committed suicide with his father's loaded and unlocked handgun hours after his junior prom in May 2000. Personally, I think that Accutane's benefits really outweigh its risks. The drug comes with a vast amount of information regarding the risks that are involved when going into the procedure, and therefore the doctors can only do so much to prevent the pregnancies and the side effects, and people are well warned before they use the drug. Because of its effectiveness and its simple to use manner, because it's just an oral medication you take once or twice a day, the drug has become a popular one, and therefore before deciding to use it, a patient should be willing to commit to his or her decision. Furthermore, I think the FDA's regulations on the iPledge program are just simply impeding the administration of the drug. After researching what the iPledge program entails, I realized that a person who can lie about his or her sexual practices to a doctor can just as easily lie to the program. Moreover, I think the program is just creating a bigger liability for many doctors and pharmacists. Therefore, if something goes wrong, doctors are responsible for the consequences. The drug is used as a last resort, and therefore malpractice, in my humble opinion, does not seem to be and should not be that big of an issue. I think the use of the drug depends on each person's willingness and commitment to comply with many strict regulations. If one does not want to think that he or she can use the drug properly, then with all due respect, don't use it. And that's my presentation. Any questions? Back there?
Yeah, you said 2,000 women had become pregnant under it. Did you read anything about the outcomes of those pregnancies?
I heard they were either mostly abortion cases, because few of them actually went through with the pregnancy after finding out that there could be possible side effects or birth defects because of the drug. And so most of them, I'm pretty sure, I don't have an exact percentage, but most of them I read that went through with an abortion. I'm actually not sure, but when they give you the drug, on the back of it, they have the outcomes if you go through with the pregnancy. They have like pictures of babies with deformed heads and whatnot, but that's the only information I have on it. And the 2,000 women, those were the reported ones. There could be more that didn't report didn't report pregnancy under Accutane. All right, thank you.
Why don't you shut this down? Our next presentation is quite timely. If you're a sports fan or you read the headlines lately, there's still a lot of debate, controversy about a certain player by the name of Barry Bonds. Accusations of steroid use now have changed to, gee, I was on human growth hormones. Our next presenter is Carvel Brown, who's going to talk about human growth hormones.
Is there something I need to push to get this going? Okay. There we go. I'm Carvel Brown. I'm going to talk to you about human growth hormone today. Human growth hormone is a polypeptide hormone, sorry. It is a substance that is found in human beings that regulates body processes. It is manufactured by the pituitary gland, which is located in the center of the head under the brain. HGH is carried to all the cells of the body, including the liver, where the liver turns it into somatomedins to initiate both bone growth and muscle growth. It also increases metabolism. HGH is referred to as somatotropin, somatropic hormone, and pituitary growth hormone. HGH is produced naturally, mainly in the early stages of life. In your early 20s and puberty, HGH levels are incredibly high, but then exponentially decrease, and soon, by the time you hit your 40s, is practically negligible. HGH consists of building blocks called amino acids. There are 20 different amino acids that make up HGH's intricate structure of 191 amino acids. Each one of these individual amino acids has its own chemical structure and therefore its own stereochemistry. These acids assemble in the pituitary gland by dehydration synthesis. It also has to come together in the precise formation of 191 amino acids and correct stereoisomer of the acid. It's able to do this with such precision with the help of enzymes. They then bond by a dehydration synthesis to form peptide bonds. It occurs when the carboxyl group and the carboxyl group of the amino acid combines with the amino group of another amino acid. One hydrogen from the amino group bonds with the OH from the carboxyl group, releasing water and combining the two amino acids. This process continues until all 191 amino acids have correctly linked. They twist together and can form a precise shape of the HGH molecule. The HGH molecule has some hydrophobic and some hydrophilic chains. These help keep the chain in the correct conformation. The hydrophobic chains attract each other towards the inside of the molecule, away from the watery solution, whereas the hydrophilic chains are attracted to the outside. The hypothalamus initiates the release of HGH into the bloodstream. It will either send the hormone GHRH to the pituitary gland to secrete more HGH, or send HGIH to tell it to secrete less HGH. HGH only stays in the bloodstream for a few minutes. It usually secretes during deep sleep. Some is carried to the liver to produce IGF-1, or somatomedin, which in turn travels to the muscles, bones, and fat cells. There, it promotes growth of muscles and bones and heightens metabolism in the fat cells. Human growth hormone takes effect on a cell to grow only once the molecule is received by two receptor proteins called HGH-BP. These two receptors are embedded within the cell membrane. They have separate portions inside and outside the cell and are combined by a helical structure. The hormone molecule has to fit precisely into the two receptor molecules, much like a substrate to an enzyme or a glove on hand. If there is any deviation to the connection, the hormone will not promote growth and may actually suppress it. Once the 2.8 extreme crystalline structure has formed, the HGH and the two receptors interact to send signals through an enzymatic response across the cell's plasma membrane into the cell. This sends information to start growth within the cell. Both receptors produce the same reaction within the cell despite the extreme difference on the binding sites to the hormone. The two binding sites between the receptors and the hormone are covalent bonds. The hormone combines at one site, forming an intermediate inactive molecule. This binding site is bonded by arginine, and then the other side of the HGH molecule is attached by glycine. These two different binding sites have different strengths, but despite this, they both send the same message and amount of information through the receptor into the cell. Growth hormone was first derived by extracting it from human and anthropoid ape cadavers. This started in the 1950s. It was considered a steroid and therefore illegal outside of a doctor-patient relationship. It was very expensive and was primarily only used to stimulate growth in children suffering from growth hormone deficiency. It was very expensive and was primarily used to stimulate, In 1958, the endocrinologist Maurice Rabin injected a child with deficient growth hormone with HGH and it began to grow normally. Thousands of children were treated with cadaver HGH over the next 30 years. The pioneering company, Genentech, produced a synthetic form of HGH in 1985. They called the product protropin. It varied from HGH in one way. It had a 192 amino acid chain rather than a 191. But soon after, Eli Lilly succeeded in making the identical HGH structure that the human pituitary gland produces. The synthetic HGH was approved by the American FDA for research and medical use in children suffering from GHD, and eventually 10 years later got approved for use in adult patients as well. This approval came from a series of experiments in the early 1990s that started to show the full potential of HGH. In 1990, Dr. Daniel Rudman of the Medical College of Wisconsin conducted an experiment by administering HGH to 21 healthy men of 60 years of age or older. These men were given 0.03 milligrams of synthetic HGH per kilogram of body weight 3 times a week. This was continued for a period of 6 months. The study showed an increase in lean body mass of 8.8%, a decrease in fatty tissue mass by 14.4%, an increase in bone density of 1.6%, and an increase in skin thickness of 7.1%. This sparked an onset of interest in the use of HGH. Inspired by Rudman's experiment, Cass Terry from the Medical College of Wisconsin and Emmett Sheehan at the Life Extension Institute in Palm Springs conducted an experiment using small frequent doses of HGH to try to match the body's natural secretion. This experiment used about a quarter as much HGH weekly as the experiment ran by Rudman. Terry Sheehan treated 800 patients. The patients showed no major side effects. The only side effects recorded were minor joint aches and minor fluid retention. These side effects disappeared after a few months of treatment. The results of the experiment showed that 72% of patients had significant weight loss, 60-70% had improved skin, a 73% had noticed an increase in resistance to common ailments, 38% reported new hair growth, 55-71% reported better healing capacities in injuries, 38% had new, or 75, yeah, that's it. Through different experimentations, several benefits have been noted about HGH. These include it benefits your T cells and B cells, promotes healing and regeneration of cells, decreases body fat without exercise and change of diet, stimulates nerve growth in the brain, raises stress resilience, boosts muscle strength, smooths and firms skin, increases healing abilities, enhances sexual performance, increases energy and memory, strengthens bone structure, amplifies cardiovascular strength, improves organ function and regrowth. Also aids in better sleep, lowers cholesterol, and regrows lost hair. These benefits have sparked an increased demand for HGH. Despite this demand, HGH is not readily available to the public. There are still concerns about its safety, and for this reason, several doctors caution against against using HGH. Taking HGH could increase someone's chances of getting diabetes and has been directly related to carpal tunnel and muscle aches. Although no direct link has been made, some researchers think that HGH could be linked to cancer. Another problem with HGH is its cost efficiency. The recommended amount would cost around $2,000 a month on a black market, or $400 a month with a prescription. Other side effects include bloating, heart failure, high blood pressure, and swelling. One other concern is that if it's unsupervised, someone could take too much HGH, or if they're already producing HGH naturally and then add more, they could get acromegaly. It's a disease that causes hands, feet, upper brows, and jaw lines to overgrow, causing deformation and other medical problems. Acromegaly is caused by the excessive human growth hormone in the body. Today, HGH is approved for use in the medical field in 60 different countries, including the US, for conditions like cardiovascular disease, human growth hormone deficiency in children, anti-aging in the elderly, and to promote T-cell health and AIDS patients. The more we learn about this hormone, the more promising it becomes for many illnesses and for cosmetics. It is illegal for the general public because it is a powerful drug that could be habit-forming and could cause unknown long-term effects. It will be interesting to see what becomes of HGH in society, but it is pertinent that we regulate its use in the early stages of understanding this complex hormone. Are there any questions?
Every week throughout both semesters, on every Monday, you received a recipe from me. Our next presentation deals with something along that line. We're going to hear about the health effects of olive oil, and to present that this afternoon is Rob Morris.
All right, many people in the Mediterranean region have had increased health effects because of their diet, and one of the main reasons for this is because of their large consumption of olive oil. And some of the health effects that have been noticed in people of the Mediterranean are that they have increased cardiovascular health and longer life expectancy rates. I'm going to go over how olive oil health benefits are due to many of the components that it has, and has a vast amount of components that actually help and benefit people. And many of you already know how good olive oil tastes and how it's used in so many recipes, so it shouldn't be too bad to incorporate more olive oil into our lives. First, there's aroma components. These are basically, they give olive oil its smell, and they help cause the differentiation of the stomach's gastric fluids, which increases the amount of olive oil that's digested by the human and incorporated into their body. And this is important because it allows some of the more helpful components of olive oil, including the tocopherols and its phenols, to be better included into olive oil. Olive oil contains phyloquinone, which is better known as vitamin K1. Vitamin K1 is used for the carboxylation of some glutamate residues in proteins and other gamma carboxylic or carboxglutamate residues, and it basically helps with calcium binding, and also is required for blood coagulation and bone metabolism and vascular biology. Deficiency in vitamin K can result in uncontrolled massive bleeding, cartilage calcification, severe formation of developing bone and depositing of calcium salts on interior surfaces of artery walls. Olive oil also contains many phenolic components, and this is the major antioxidant within olive oil. And it contains so many of these different phenolic compounds that it helps with many things. It depends, like which ones it contains depends basically on the cultivar of the olive, where it was grown, what temperature, and all the certain conditions of how the olive was raised. But basically, phenolic compounds are, they assist with the oxidation and blocking that, and they're powerful antioxidants. Some of the pigments in olive oil are chlorophyll, phenolphthalein, and carotenoids. They give olive oil its distinct rich color, and they help olive oil also be incorporated into the body by helping with the gastric fluids as well, same with aroma compounds, and it helps its phenolic and tocopherols to be better absorbed. The main part of olive oil is oleic acid, and it makes up 55 to 85% of olive oil. It's a monosaturated acid, which means it only has one double bond, carbon-carbon double bond, and it's a omega-9 fatty acid, which is essential for human health. It's been known that it reduces LDL cholesterol and increases HDL cholesterol, and this is important because LDL cholesterol, when it becomes oxidized, it sticks to artery walls and is the main reason for heart attacks and cardiovascular disease. And HDL is the good cholesterol, which can't be oxidized as easily, and it won't stick to the walls. It also contains scalene, which is a biochemical precursor to the whole family of steroids. Upon the oxidation of one of its terminal double bonds, squalene is made into 2,3-squalene oxide, which undergoes enzyme catalyzed cyclization to produce landsterol, which is then converted into cholesterol and other steroids. It's basically the precursor to all steroids. Olive oil also contains tocopherols, which is better known as vitamin E. There's 4 types of vitamin E, and olive oil contains all 4 of them. It contains alpha, beta, and gamma. Vitamin E is another very important antioxidant that olive oil contains. Its tocopherols hydroxyl group donates a hydrogen proton, which is capable of reducing free radicals, which then protects vitamin A and other essential fatty acids from oxidation. And because it has a hydrophobic side chain, it makes this a fat-soluble vitamin, and it allows it to enter into cell membranes where it can prevent DNA, cellular membrane, and organelle membrane damage from free radicals. And like I said, olive oil's health benefits are demonstrated. It's free radicals. Basically, a free radical is made when a molecule is split in such a way that it's left with an unpaired electron, creating a very reactive molecule which will attack other molecules in order to take an electron to make an unpaired electron more stable. And this in turn makes that molecule another free radical, and this is a cascading reaction which can be very damaging to the human body. It oxidizes cell membranes, organelle membranes, and DNA, which are polyunsaturated fats. And it causes cancer, liver damage, and is believed to be the reason why we age. It's made during a metabolic process, or you can have them breathed in from the outside, like from cigarette smoke and pollution and other factors. Olive oil contains many antioxidant compounds that donate free radical to stabilize the free radical. And it includes vitamin E, which I told you about, phenols, it's many phenols, chlorophyll, and its carotenoids. It also protects against cancer. The main cancers that it protects against are both colon cancer and breast cancer. Oleic acid reduces the expression of H2 new oncogene, which is associated with aggressive growth of breast cancer. And olive oil's effects on colon cancer are related to its ability to reduce the number of causogenic heterocycloamines, which are formed during cooking meats. So if you cook with olive oil, cook your meats with olive oil, not only is it going to taste better, but it's also going to make it a lot healthier for you. As I told you before, with cholesterol, olive oil reduces the HDL to LDL ratio. Its biophenols, mainly protocatechinoic acid and opaferin, help to prevent LDL oxidation. If LDL becomes oxidized, it sticks to the artery wall, and that's the cause of cardiovascular disease, which is the major killer of Americans. Olive oil is also anti-inflammatory, and inflammation is a natural defense of the body, which basically is a response to an irritant and is associated with swelling, redness, pain, heat, and dysfunction of involved organelle. The way leukocytes fight off the infection is harmful to the body's tissues, and the way the body uses omega-6 fatty acids creates inflammatory compounds as well. It builds up, or fatty buildups lining blood vessels can become inflamed as white blood cells misguidingly invade them. Chronic infections lead to inflammation to fight off the infection, but if it's chronic, it's going to be long lasting. So, and high blood pressure as well as smoking are all sources of inflammation. And olive oil, basically its anti-inflammatory compounds are squalene, beta-sterol, and tristol, which inhibit the production or render harmful molecules produced by the omega-6 fatty acids harmless. It's monosaturated fats, which is oleic acid, the main one, are used by the body to produce anti-inflammatory compounds, which decrease symptoms of asthma and rheumatoid arthritis with constant use. So people who have been suffering from those diseases, when they consume olive oil on a regular use, their symptoms are decreased. And another interesting component of olive oil is orthocanthal, which works the same way ibuprofen works, except orthocanthal does not contain or does not hurt the intestinal tract like ibuprofen does. Ibuprofen causes intestinal bleeding and kidney damage, and orthocanthal does not attack the same way, but it works the same way of being anti-inflammatory. Olive oil, 2 tablespoons of extra virgin olive oil contain about 5% of regular dosage of ibuprofen. So it's not a substitute for ibuprofen, but if you consume olive oil regularly, you're seeking those benefits along with your consumption of it. Olive oil is also used to help against osteoporosis. Osteoporosis is caused by insignificant mineral depositing, and new molecular evidence has basically found that it's also caused by inflammation too. And olive oil's phenols and opaferin and hydroxytryptosol decrease inflammation-mediated bone loss involved in osteoporosis. Also, osteoporosis is caused by obesity, which has been shown to be inflammatory. And when olive oil, a monounsaturated fat, replaces other saturated fats in someone's diet, it's actually been shown that it helps to aid in weight loss. So basically, due to olive oil's amounts of health-promoting components, it has a huge effect on general health, but should not be over-consumed, because if you overconsume it or you just add it to a pre-existing diet, it's going to actually be more harmful because it is fat. It's 100% fat, so you're just adding that. But if you can replace like things such as butter and margarine and other things like that in your diet, it's a healthier step that's a lot easier. And it's recommended amounts to take are about 2 to 4 tablespoons a day, and it's, as you can see from people of the Mediterranean, they have higher life expectancy rates and lower cases of cardiovascular disease. And I think that about concludes it. Are there any questions? Yeah.
I was wondering if anything
They said it affects it sort of, but the way olive oil is it works so well that it's really good for use in heating things, and like I said, with cooking meats and stuff like that, and vegetables. It doesn't degrade it nearly as much as other oils. Like if you took canola oil or some of the other fats, it decreases it a little bit, but the health benefits from that are still significant. Is there any other questions?
Let me get this off first. There we go. I think it's in here. Let me just do this. One thing I'd like to do while we're getting set up on the next presentation is acknowledge our college president, Dr. Mary Kay Kickles. Would you please stand? This has been final exam week, and I think at the beginning of this week, this paper that's going to be presented was probably something we really needed, a little bit of deep brain stimulation. To present this afternoon is Delpreet Kaur.
Hi, I'm Dilpreet. I would like to talk about deep brain stimulation. Deep brain stimulation is new and improved surgical treatment for patients with neural and muscular damage. And it's the technology that's currently being used. It's been developed and is changing the lives of many individuals. Deep brain stimulation is the technique that involves implantation of electrode directly into the subthalamic nucleus of the brain, and this electrode is then connected to the wires, and that's buried under the skin. And this wire is then connected to the small electrical device. It's called the neurotransmitter. This neurotransmitter, it's placed under the skin in the chest. As you can see in the picture, this is the electrode. The electrode is then connected to the wire. It's the coiled wires, and then it goes down to the neurostimulator. History of deep brain stimulation. The roots of deep brain stimulation method for treating diseases that cause undesired tremors of the body muscles can be traced back to the early 1900s. In the 1980s, it was realized that the electrical stimulation of specific parts of the brain could be used to decrease tremors in Parkinson's disease patients. In 2002, FDA, Food and Drug Administration, approved deep brain stimulation as the treatment for Parkinson's disease patients. There are some risks involved in deep brain stimulation. There's a 2 to 3% chance of brain hemorrhage, paralysis, speech impairment, and strokes. And there are some temporary problems related to deep brain stimulation. There are some infections in the brain due to the implantation of the electrode that's placed in the subthalamic nucleus of the brain, and this causes infections this causes the temporary infections in the brain. And there are not many risks involved in the surgery because the electrical system implanted during the DBS functions really well in the brain. There are some medical problems related to deep brain stimulation. The use of the neurostimulator to produce DBS can be used for many different types of diseases. All of the diseases treated today with DBS can be related by their neuron malfunction. This disease is caused by the neuron malfunctioning when the neurons cannot function really good. This malfunction can either create unmanageable movement or disorders, just like in Parkinson's diseases, like Parkinson's disease patients. And diseases are affected by neurons abandoning their normal electrical functions, which cause them to start misfiring really wildly. When the neurons start firing really wild, and this act from the neurons causes uncontrollable movements or behaviors. This is the picture that shows the firing of neurons. And by using neurotransmitter, the misfiring of cells are electrically stunned. You can reduce the firing of neurons by using the neurostimulator. It shocks the nerve cell, and which reduces the firing of transmitter neurons, which results in a decrease of uncalled movements or behavior. The future of deep brain stimulation. Development of DBS technology is of great interest to researchers these days. Research has showed that DBS can be used to relieve patients from nerve-related pains. The National Institute of Neurological Disorders and Stroke supports research for the DBS system to ensure that it is safe and reliable for the patients. It also supports scientists that are trying to find the most suitable sites in the human brain for the implantation of DBS. Although the goals of DBS sounds exciting, it will take years before the scientists can achieve these goals. Deep brain stimulation is one of the most successful approaches for the treatment of diseases caused by severe nerve malfunctioning. During DBS, electrical impulses are delivered by implanting surgery electrodes within the brain. DBS shocks the nerve cells, causing a decrease in the firing of neuron transmitters, which results in a decrease of unwanted movement or behavior, just like in Parkinson's disease. As the device has proved to improve the condition for most of the patients almost always immediately after use, many diseases will be treated by this method of deep brain stimulation in future. Any questions?
I have a question.
Sure.
How many joules of energy or voltage is supplied in this?
Oh, I don't know. No, there are 4 wires coiled together that's attached to the electrode, and then that goes down to the neurotransmitter, but I'm not sure how much energy is used in the neurotransmitter. Yeah.
Do you know what regular time the neurostimulators are, or frequency at which it fires?
It's buried inside the skin. I guess it's always working like the pacemaker does. So, sure.
There's a number of psychiatric diseases involving misfiring of neurons like obsessive compulsive disorder or schizophrenia, bipolar. So did any investigation using this instead of electroconvulsive therapy for psychiatric disease?
As far as I know, DBS is only used for the muscular damage. It's not. I haven't read about this damage. It's just the muscular and neural damage it's used for.
For those that arrived late, I want to remind you, as I did the others, that at the conclusion of the presentations this afternoon, you'll be getting a disc of all of the papers. You'll be getting your paper back with your paper grade, your final exam grade, and your final grade. And that'll occur at the conclusion of our presentations this afternoon. Next, another timely topic, hydrogen, the clean alternative. John Lamy.
All right, I did my presentation on hydrogen. Titled it "The Fuel of the Future." Hydrogen was first discovered here in 1776 by a chemist, Henry Cavendish, and he named it hydrogen, meaning hydrogenous, which means water forming. It accounts for about 90% of the atoms in the universe, and Henry Cavendish also discovered that when he burned it, it formed water. Hydrogen releases a lot of energy when it's burned. It'll release about 25 kilocalories per gram. That's a lot compared to 10 kilocalories per gram of natural methane gas. Fusion is the process of combining two hydrogen to create a helium and energy. 4 grams of hydrogen combine to form about 4 grams of helium and about 2.5 billion kilojoules of energy. This is the process that's used in the sun to create the heat that we feel. And there's a program currently underway called it's called the ITER. It's the International Thermonuclear Experimental Reactor, and it's a joint project by multiple countries to produce the first fusion reactor. And that, when they're doing this, what they do is they combine a hot plasma and a magnetic field, and the plasma must be compressed to about 20 times the weight of lead, and it must be heated to 150 million degrees Fahrenheit. And under these conditions, it'll run the same reaction. The reactor core, they predict, will be able to produce about 500 megawatts, and they think it'll be done by about 2016. Another type of fuel that you can use is the fuel cells, which we will start seeing in cars soon. The fuel cell has been around since like the 1800s, but nobody's really looked into it as an alternative power source until recently. The process of getting power from the fuel cell is essentially you take 2 hydrogen or 2 H2s and combine it with 2 oxygens, and it produces water and an exchange of protons, and it's those protons which actually give the power to the electrical device. This is the cleanest source of power on the planet since all it produces is water. One of the problems with using hydrogen power is where do they get the hydrogen from? Hydrogen exists all around us, but it's not necessarily in a usable form, such as like water, or it actually exists in the atmosphere. So we just have to have a means of acquiring it. One of the means of acquiring it is electrolysis. And electrolysis is basically the opposite of a fuel cell. And basically you are running electric current through water, and it produces 2 hydrogen and 2 oxygen. One of the problems with electrolysis is you need energy in order to split it. So you need some sort of energy source to begin with in order to create the energy to make an energy source. So one of the options is pairing it up with something like solar or wind if you want to make a clean power source. Another process is extracting the hydrogen from the hydrocarbons. Hydrocarbons, their commonly used one is natural gas. And in high pressure and with a catalyst, it'll yield hydrogen. Once again, one of the problems with this is that it requires energy to get the hydrogen. Another option is biomass. It's actually called biomass gasification. And in this process, they use things that biomass such as straw, solid waste or sewage, and forestry byproducts, and when it's heated with little or no oxygen, it'll create hydrogen. Once again, this one needs energy to produce the hydrogens. Another option is the tandem cell, which is produced by a company called Hydrogen Solar. And the tandem cell is essentially a solar and like electrolysis bundled in one package. And I mean, it's basically like it is. I guess that's all I got on that one. Molecular synthesis, I guess they have been looking into creating molecules that will produce hydrogen from water. And they produced one, which was an inorganic molecule. And with deep UV light, it would produce hydrogen from the water. But one of the problems with this is that it requires deep UV light, which is blocked by the atmosphere, by the ozone layer. So it's not really a viable source of hydrogen at this point, but they predicted it'd be something that they could use during like space travel or something like that. Another problem that's associated with using hydrogen as a power source is a means of storing it. Since hydrogen is much less dense than air, it will obviously escape things that aren't sealed very well, and also it takes a lot more, like it's very spread apart, so you have to like compress it in order to store it into a easily maneuverable thing. One of the options is compression. Compression is one way of storing the hydrogen, and it greatly increases the density. Quantum Technologies has actually produced a couple of these compressed hydrogen tanks, which they currently have in a few concept cars. And they have a couple, they have the 5,000 and 10,000 PSI tank. One of the problems with this is that you need you can use like a heavier metal in order to store it, but they're looking towards using it in cars and stuff, so you need like a lighter material such as carbon fiber, and the carbon fiber is really expensive, so it makes these tanks pretty expensive. Another option is liquid hydrogen. Liquid hydrogen units, they basically cool the hydrogen down to about negative 253 degrees Celsius, and at that temperature, hydrogen liquefies. The liquid hydrogen tanks can actually store more hydrogen than the compressed tanks can. The only problem with this is typically a large part of energy that the hydrogen makes is required to maintain the cooled state so that the hydrogen stays liquid. Another thing that's required for hydrogen to become used on a daily basis is infrastructure, and that means just like having it available to the public, such as hydrogen fueling stations. Currently underway is the California Hydrogen Highway, and that's like a picture of all the stations that they have so far. It's basically a project to create a infrastructure in California for hydrogen fuel vehicles, and it's currently in early development, and they only have like 16 around the state right now, but they've planned 150 to 200 throughout the state. And they predict that should be done by about 2010. And let's see, there's a couple others that I read about. There's one in British Columbia. They're trying to put together a similar hydrogen highway for the 2010 Olympics. And that should be done by 2010. Also in Sweden, they're building a similar type of thing. Sweden is a good place, or the place in Sweden where they're trying to do it actually produces a lot of hydrogen as a byproduct from chemical, like making chemicals and stuff. And also it's like the one of the places that Volvo is based, so it's kind of like there's hydrogen there and car makers there, so it's kind of a good situation there. Let's see. Lastly, I got some of the cars. Basically, there's two types of hydrogen cars. There's the, they have hydrogen internal combustion cars, and they have the fuel cell cars. Let's see, this is the GM sequel, yeah, and it is just a concept at this point, but I actually read they had a car and driver report on it, and they actually ranked it really high. It actually has really high, like it can go pretty far without needing a refuel. It gets about the equivalent of 39 miles per gallon, and you know, it basically operates like a regular car, except for it uses hydrogen. And this one is a fuel cell car. Another one is the hydrogen curry car. As you can tell from the picture, it's actually being used. It is basically, it's based off the Opel Zafira minivan, and it is used in around Washington, D.C., and also in California for essentially, like right now, the most of the vehicles that are being used for the hydrogen are used by like lawmakers and stuff. They're trying to, like, you know, give them free stuff so that they kind of promote these things. And as you can tell, like another thing that I read, that you can see Shell in the background there. You'd kind of think that, you know, gas companies would stay away from, you know, not want the hydrogen around because it would affect them. But some of them are adapting and, you know, picking up hydrogen because they see that it's the future, and they think they can get on it. If they get in on it early, they can make money off of it. Last car is the Ford U concept, and this is a internal combustion vehicle, and this one's just obviously a concept, and I didn't really read that much about it. So, and in conclusion, I think hydrogen is a viable fuel source. Really, all that's missing now is its availability and you know, a means of creating the hydrogen. Like it says here, there's a few problems that must be overcome, such as storage, the means of producing hydrogen, and an infrastructure. But in my opinion, I think everything in the future will be hydrogen. Most of the companies, the car companies, say that the hydrogen cars will be available to the public around 2010. So I kind of figure if they come out 2010, probably by 2015 it'll be pretty widely used. So you still got a few years to wait. And that's all. So any questions? Yeah.
We use a lot of cars that run on hydrogen, and you said that one of my products was water.
Uh-huh.
So we don't have to run water.
No, I actually read about that. They said that it does produce water, but it's much like currently gas cars produce water also. It's so little you can't see, and it would produce about the same amount of water, except for you won't get the carbon dioxide like the gas vehicles produce. Anything else? All right, thank you.
As we transition into the summer, and as you leave here today and the sun affects you, as you start to sweat, there may be something more going on than what you think. Stephanie Fong is going to talk about armpit sweat as a human pheromone. Stephanie.
Okay, so I'm going to talk about armpit sweat as a human pheromone. For many different people, there are a lot of things that make others attractive. Some people think Brad Pitt is attractive. I beg to differ, but facially, he's very symmetrical, but that's not the only quality that makes him attractive. I know a lot of you have not smelled his armpit sweat, but that's why ugly people can get dates, because of their armpit sweat. And there is evidence to prove that armpit sweat does help people be more attracted to the opposite sex, or the same sex if they are homosexual. In 1979, behavioral endocrinologist Dr. Winnie Cutler announced the male secreted hormone androstenone. While everyone secretes androstenone, mainly males secrete androstenone more. It affects the hormonal behavior of women. Her experiment consisted of gathering 45 sexually active men who were of varying ages, and they were each asked to wear an absorbent padding under their arm for 20 hours a day for 2 weeks. This was the same padding that they used every day. Concentrated sweat was extracted from the padding and diluted into a liquid form. The next part may sound gross, but I don't think the females smelled it at all, or consciously smelled it. But the liquid sweat was then topically applied daily to the upper lip of 35 sexually inactive, irregularly menstruating women for 14 weeks. The definition of a non-regular menstruating woman is plus or minus 3 days from the 28-day cycle. Another group, a control group of 35 sexually inactive, irregularly menstruating women was gathered, and a placebo was placed on their lip for the same period of time. The results gained after 14 weeks showed that 80% of the 35 women receiving the diluted armpit sweat reported regular menstruation cycles for the previous 2 months. Only one person in the control group reported a regular menstruation cycle for the previous 2 months. Dr. Cutler performed this experiment in 1986 and 1991 with similar results. Her interpretation of the results was that something in male sweat affects the reproductive behavior of females. Human sweat is mainly composed of androstenone and water, so she theorized that androstenone must act as a pheromone. There's a picture of Hugh Hefner. It must be the sweat. So what are pheromones? Pheromones are chemical messengers that are transported outside the body and have the potential to elicit particular physiological, psychological, and/or behavioral changes in a member of the same species. For instance, dogs sniff other dogs' genitals and anal regions because there are mating pheromones present in canine urine and feces. There's a picture below if you don't want to visualize it. Also, cats rub their faces on their human owners to mark their territory and warn other cats to get lost. In humans, androstenone is mainly found in the apocrine glands, but it can also be found in urine and saliva. And this is also why humans kiss each other, because they're checking out each other's androstenone. And maybe it's why men don't put the toilet seat down. Apocrine glands are located in areas of the body where pubic hair is present. The highest concentration of apocrine glands is in the armpit, and this is an actual picture where she did have armpit hair under. It wasn't fixed or anything. So how do pheromones work? Well, odor molecules bind to the receptors on the inside of the nasal cavity. Axons of the sensory cells become excited and enter the olfactory bulb of the brain. Signals travel from the olfactory tract to the olfactory lobe of the brain and then to the limbic system. The limbic system interprets the sensory message and sends the appropriate response. Here's a recap. And then I just threw this in. So the structure of androstenone is typical of a characteristic steroid structure, and it has at least 19 carbons in 4 fused rings. The chemical formula is C19H28O, and it has a molecular weight of 217.19 AMU per mole. The stereochemistry of androstenone, it has 5 chiral carbons. There's S stereochemistry present at C9, C10, and C14. There's R stereochemistry present at C8 and C13. So how does androstenone form? Androstenone is actually the precursor to testosterone and estrogen. It forms from cholesterol, and cholesterol forms pregnenolone, which is then formed into 17-hydroxypregnenolone, and then to DHEA, followed by androstenedione, and then finally androstenone. The first step in the synthesis involves pregnenolone, oxygen, NADPH, which is found in mitochondria, and hydrogen. And it reacts with cytochrome 450 to produce 17-alpha-hydroxypregnenolone. In order for the pregnenolone to become activated, cytochrome 450 has to work. Cytochrome 450 is an important enzyme for mammalian metabolism. It activates oxygen so that the hydroxylation of pregnenolone can occur, and this is a very good compound because the heme group is capable of undergoing redox reactions with oxidation states of +2, +3, and +4. I'm not going to go through the whole steps, but the mechanism for this is that a radical intermediate is created when the cytochrome 450 donates an electron to the pregnenolone, and so the radical becomes 17-alpha-hydroxypregnenolone when it bonds with the hydroxy group on the iron atom, and the iron atom will go back to its original state. The second step in the synthesis of androstenone is from 17-alpha-hydroxypregnenolone to DHEA. The enzymes used in this is 1720 lyase, and it catalyzes the cleavage of CC bonds without hydrolysis or oxidation to form at least 2 molecules, one of which contains a double bond. So now there's a double bond at C17. There's a ketone at C17. And it requires cytochrome B5, and it's similar to cytochrome 450 in that a radical intermediate is created, except in this, a keto group is now formed on C17. The second to last step is DHEA goes to androstenedione, and that occurs when the 3-beta dehydrogenase, which is an enzyme, it oxidizes the hydroxy group on the C3 group by transferring a proton and a pair of electrons to the NAD+. The double bond on C5 is interconverted by the isomerase. And then the final step is from androstenedione to androstenone, and an enzyme required is the 17-keto steroid reductase, which reduces the ketone on the C17 to form a double bond on C16, and that gives you the ketone product. And the final products of this are androstenone and NAD+. So what are the effects of androstenone? There are more effects. And one of the major effects is that people become more sociable after being exposed to the chemical. Male and female participants, and this includes a wide range of ages and sexualities, were asked to rate pictures of trees, animals, and other humans. Freddy Krueger was not a picture that they saw, but I just put it up there. The group wearing androstenone lace masks wore their masks for at least 10 minutes prior to the test, and the control group did not wear androstenone lace masks. And the results of the experiment showed that the experimental group had softened opinions of other people, rating them as nice or pleasant, and the control group remained indifferent. Currently, armpit sweat is being marketed in a bottle. It's being synthesized in labs and being marketed as a love potion. It consists of androstenone, water, and a mild fragrance. And cologne or perfume can actually mask the odor of armpit sweat, so they make sure that the mild fragrance added does not mask the actual smell of androstenone. The marketing for this product has focused on men using the product to attract women or homosexual men. Primal for Him, Sex Boost, and Spray of Love are just a few of the names being given for the chemical, and prices range anywhere from $40 to $150 per 1 ounce bottle. So what are some biological applications of the future? There could be new ways to regulate menstrual cycles in women. As shown by Dr. Cutler's experiment, many of the irregularly menstruating women were able to menstruate after being exposed to androstenone. A second biological application is a better understanding of the biological basis of heterosexual and homosexuality. It has been shown that large secretions of androstenone will attract homosexual men to other men. And could this be a better aphrodisiac than alcohol? It's certainly a less intoxicating one, so there's questions for the future. Does anybody have any questions? Yes?
Most of the market and most of your studies seem to focus on the effects of women. What about the effects of men? Do they respond to it?
On the effects of men? Yes, men actually respond to it, but studies have more focused on homosexual men rather than heterosexual men responding to the androstenone secreted by women, because women don't sweat as much as men do. And so this, what?
Women don't sweat, they blow.
Yes, women don't sweat at all, actually. That's a misconception. Are there any other questions?
This will conclude our presentations this afternoon. First of all, I want to acknowledge all the presenters. If we could have a nice hand for the presenters. Your time with me has come to an end. I've enjoyed the 2 semesters with all of you. I look forward to seeing you do many great things. You've learned a lot. Hopefully you will apply that and make this earth a better place to live in. As soon as I'm finished, right in the back where I've been sitting, please meet me there. We have discs for you. We've got your papers. Other than that, thank you all for coming this afternoon. Sarah. They want you to get the purse.
In doing well, and I'm sure it makes a difference in the amount of time that they study for their courses.
Those may be some of the people who can afford to work a little.
Right, that's a good point. I didn't think about that.
But also, I think, if you have to work, that's okay. Just get in your mindset that if you're going to have to work, if you've got other big commitments, if you have children, things like that, you want to maintain some balance. Just tell yourself it's okay then to get the C's. Don't expect that you can raise kids, work part-time, go to pharmacy school, and be in the top 1%. That's just absurd. But we see it all the time. You probably know people that are sort of like that think that they can do it all. They're the ones that burn out. So if you have some other important constraints on your life, good. That's fine. Just don't expect as much from yourself.
And it depends why you're working too. I mean, if you're working for an extra little couple of bucks, then that is just not worth it. If you're working because you like the experience and you're able to handle it, then that's a good reason. I mean, but you know, you're not gonna be able to work at all if you don't pass the classes, so it just depends on the reason.
Are any of your classes give you hands-on training, and more focused on hands-on training instead of the textbook material?
Yes, we do have 2 shadowing experiences, first and second quarter, that they assign you to a hospital or a community pharmacy. We get to shadow, and then beginning your second quarter, you have 10 weeks where you're on rotation with community or